Hello everyone, my name is Brendan Sieco. I'm the founder and CEO of QZAM, based up in Boston. In the next half an hour, we're going to explore artificial intelligence in museums. Artificial intelligence has gone mainstream. Everywhere you turn, there's some sort of headline in every major publication. ABC, NBC, Forbes, Wired. It's kind of exhausting, another flashy headline. Stephen Hawking is saying artificial intelligence could be the end of mankind, and others are saying it's the next big thing. You might see predictions and products by every major technology company, and even a museum exhibition at the Tate, which opened this fall. So loud and clear, AI is everywhere. It's a really hot topic. So you might have seen a couple of these headlines. These are just a few that have popped up in the last couple of days. Raise your hands if you've seen anything in the last week in your news feeds about AI, machine learning, machine vision. Mark Zuckerberg trained his toaster to print pictures of him. It's crazy, it's mayhem, it's everywhere. So there are some good ones up there, especially this one in the middle. What the F is machine learning anyways? So artificial intelligence is comprised of many moving parts. The broader concept, of course, is to mimic the human mind. But today we'll talk about just a few of these pieces and how they impact museum practice. Let's start with machine learning. Well, what is machine learning? Machine learning is a method of data analysis that automates analytical model building using algorithms that iteratively learn from data. Machine learning allows machines to find hidden insights without being explicitly programmed to look for. That's a mouthful of technical jargon. I think the emphasis here is on a machine's ability to learn without explicitly being programmed to do so. So let's talk about a couple areas of museum practice and operations where this could have a really big impact. We'll start with collections. It comes as no surprise that museums have tremendous amounts of data, and strides have been made over the past decade towards structuring collections data and making it available for the public to access and experiment with. While still highly untapped, this valuable metadata holds power and yields interesting ways to analyze museums' collections, objects, and creators in new ways. But also, as we all know, this requires lots of resources, tools, times, and expertise to work with. So in an ideal world, galleries, libraries, archives, museums, collection data would be structured and well classified. But taking into consideration that more than 90% of enterprise data is unstructured, we'd make the assumption that museum collection data could also use a little bit of cleanup, even an overhaul. So could AI come to the rescue here and even help museums make new discoveries in their collection? Those working with museums' collections management systems could train a system to effectively clean up, classify, and further understand their data. So if you want to run a quick sentiment analysis across the title and didactic text of every object in your collection, that would take months, that could take years. But in a couple lines of code leveraging existing solutions, these are things that are possible today. Now on to ticketing and attendance. Imagine taking those massive sets of data around ticketing and visitor traffic and using artificial intelligence to look for clear correlations between things like social media activity, weather, advertising spending, and other variables. It's safe to say that you discover new insights and information that could be used in making predictions around crowd flow, allocating staff resources, and overall planning more efficient. Online commerce, and I will say the first half around machine learning is quite boring and dry. We're going to get to machine vision, and that's where the magic is going to soon happen. So major e-commerce sites like Amazon and eBay and Zappos, they've been using recommendation engines for as long as anyone can remember. By analyzing your behavior, the pages you visit, the products that you look at, and the categories you explore, retailers have been able to make recommendations and provide a more personal experience to each visitor. So many museums, stores already use recommendation engines. There's really nothing new here. But coming soon is a bigger concept around conversational commerce. Chris Mencina at a company we all know called Uber said 2016 will be the year of conversational commerce. So what might that look like in the museum practice? Well, I arrive at MoMA's online store and a message pops up on my screen that says, "Hey there, how can I help you today?" Well, I'm looking for a gift for my mom. Well, what type of work does your mom like? And that would be facilitated not by a human, but by a bot. And those things lead us to the next point of a broader theme around automation. There's a lot to be said about automation. In fact, AAM Center for the Future of Museum blogged about automation a couple days ago. And so looking at kind of the day-to-day things, the operational things, it would be awesome to be unshackled from certain mundane tasks so you can focus on more connected, impactful things. There's lots of quick and easy questions to be answered by a chatbot. We're probably already interacting with chatbots on the day-to-day and don't know it. And lots of time can be used by scheduling bots. So there are a lot of little nitty-gritty things that are available today that are just basically in line with productivity and efficiency. So membership and fundraising, think again about all of the data you've collected. Your membership teams, your development teams, they've amassed so much over the years. So pattern recognition could be easily put in place to help museums identify members who are likely to renew, upgrade, and lapse. And it could assist development teams on their fundraising efforts by deciphering trends, navigating the social graph, and automating aspects of donor outreach. I was surprised to find in the last couple of months that there are 2 companies within about a 1 or 2 minute walk of my office in downtown Boston that are taking this approach. They're using machine learning to help with fundraising processes at nonprofits. So now on to the more visual, the more interesting stuff, in my opinion, is machine vision. And the concept, the definition is very, very simple. It's the machine's ability, the computer's ability to understand what it is seeing. There's a great quote from one of Silicon Valley's futurists. He's a partner at Andreessen Horowitz, who has an awesome blog and podcast that's basically, we're going from computers with cameras that take photos to computers with eyes that can see. So it's amazing to see, and just before this presentation, I walked up to a couple of these paintings, took a picture, ran them through a system, and it identified 3 dogs in front of a car, 2 dogs in front of an animal skull. So computers have the ability to see, and we'll talk about how that will impact various aspects of the collection in a moment. So identifying subject matter. Machine vision has become advanced enough to detect the subject matter and objects depicted in an image. So basically, what is depicted in this painting, this photo, this video, or sculpture? So to put this all to the test, I used Google's Vision API to test one of Canaletto's paintings, the Grand Canal in Venice, which is over at the Getty. Maybe it was beginner's luck, but the 4 terms that were returned, and this was the day it was announced before any formal training had taken place on this platform, was watercraft rowing, gondola, and painting. And all of these were accurate descriptions of the subject matter and objects. So there's still a lot of ways to go with object classification, but it's worth noting that the more you train the machine, the more accurate it becomes. So you could imagine taking thousands or tens of thousands or hundreds of thousands of images and running them through a system like that. So sentiment analysis on the visual side, there's an unobstructed human face. So think a smile, the eyes, the angles, and so on. A machine can be used to determine the emotional state of those portrayed by analyzing facial characteristics. So to put this one to the test, we ran a few portraits through the emotional API of Microsoft Project Oxford, Cognitive Services. And what did we find? Well, this Picasso painting we found to be neutral with a little lean towards sadness. And so every emotion, anger, contempt, disgust, and so on, is quantified. There's a value there. And this portrait, I love German Expressionism. There's an Otto Dix self-portrait in Detroit, and you can see this leans towards anger. And then lastly, this great piece over here by Rembrandt, you can see is incredibly happy, or at least the machines say so. So there's some interesting things that can be done with this, and in a few minutes I'll point to what's being done over at the Tate. But before that, we'll jump into text and character recognition, which frankly, it's been around for quite some time. So if you want to extract text from every object in your collection, the visual, there are tools commonly referred to as optical character recognition, or OCR for short, that have become accessible and much faster to use via the Cloud API. So I saw a while ago the Cooper Hewitt did a project with a label reader that used OCR. So there have been a couple instances of that. So the function's value could come from extracting text from every object, written documents, historical letters, postcards, and so on, so that it's searchable and easy to classify. So we take this Ed Rocher piece that was in an exhibition at the Hammer in LA, and so it's named California Grape Skins. That's all there is associated with the record. But as you can see, in one of these machines or one of these APIs, when hit with that image, can decipher all of the text, even the language in which it is written. Onto authenticating art, which isn't something I think most folks deal with the day-to-day. You know, years back, PBS Nova, they covered the case of computers helping distinguish between forged paintings from the original masterpiece. And this was in cooperation with the Van Gogh Museum, Princeton University, and Maastricht University. So essentially what they did was these computer scientists were challenged to build tools to analyze the brush strokes and identify the forgeries. And so everything you're seeing here visually was broken down into numbers and angles and so on. And it's quite amazing that they're able to do this so successfully with not maybe, you know, with the pretty big set of Van Gogh paintings, but not hundreds or thousands. I think it was a couple dozen. And recognizing similarity and patterns between works in your collection, there's a lot of application here as well. So if there are works in your collection that are similar or not similar based on subject matter or visual composition, a computer can see those relationships and quantify those differences and similarities. So I was over at the Clyfford Still, and we approached this room where there were the replicas. And so this idea popped up, well, how accurate are these? They're said to be replicas, but it'd be interesting to see what a computer would see. So with the two paintings, you know, we're inspired by this scene to see just how accurate they were, and they're 94.49% accurate, which is absolutely incredible to know that they're replicas and similar, but the artist had the level of technical ability when it came to the composition of the painting. Back home in Boston at the Museum of Fine Arts is this grand Impressionism gallery, and I was walking through with a couple of members of the museum and a couple of members of my team, and there are these two stunning Claude Monet pieces side by side, the water lilies, and we were discussing the use of image recognition as a great, easy way of accessing information about the works, and someone said there's no way that's possible, but really it absolutely is, and it's quite easy to do so. So according to computer analysis, these are 96.81% similar, which is really, really, really close, but even that slight differentiation allows a computer to pull up the information related to one versus the other. So kind of throwing a lot of these ideas together, you know, as I mentioned earlier, artificial intelligence is the topic of a museum exhibition in a project at the Tate Britain. It was the winner of this year's IK Prize, which utilized various aspects of machine vision, such as subject matter identification, composition, and facial recognition. And so what they did, which was really, really incredible, there should be a video playing here, was they took all of the collection, all of the Tate Britain's collection, and they analyzed it using a number of different tools. And then they took real live feeds of what was happening in our own world, news articles from AP and Reuters and so on, and they would pair them based on a number of different criteria. And this was really, really timely in that the New York Times just did a piece last week called Artificial Intelligence as a Bridge for Art and Reality. It's a great article by Judith Dobrinsky, highly recommended. And here was one of the specific examples that they point out. So you can see this great painting, and then this completely unrelated, or at least the picture aside, a photograph of a couple at an Afropunk festival that took place in Brooklyn, New York. And so you start to look at the piece in a completely different way, and this was paired not by a curator or a human, but by a computer. And so on this topic, it was really interesting. The president of the Getty, who's an evangelist for the use of technology by art historians, talked about recognition, the name of this project, as a well-meaning and interesting experiment. And then he added, it shows that we are in the very early stages of development with this technology, and there's still a long way to go, which I absolutely agree with. But it's been amazing to see just in these few years what's been possible with access to these new tools. So machine learning and machine vision are very powerful tools and more accessible than ever before. And I think the key here is accessible. AI and machine learning, machine vision has been around for a long, long time. But now anyone can tap in, and Harvard Business Review put out a piece, I think it was last week or the week before, that said AI is no longer for experts. Anyone has the ability to tap into these resources. And on a broader AI, creative bots are already creating paintings. They're writing screenplays and composing music. So there's a lot of questions here. Will AI be writing object labels? Will it be scripting audio guides? Can it assist with interpretation in the years to come? Do we want to let the machines do this? I think is also the bigger question. Those are some of the things to ponder here. But in the hands of museums, these technologies will inevitably lead to interesting discoveries, richer data, and new paths into your collection for you and your visitors. So if you're ready to take a dive or at least mess around, I've talked to a number of people here that said they were doing some experimentations, for instance, at the Harvard Art Museums with Google's Cloud Platform and the Vision API. There's a lot of tools, and the great thing is a lot of these are free. So if you want to tap in and experiment and create your first chatbot, there are interfaces that allow non-technical members of your team to kind of experiment and go from there. And I know Microsoft's been really supportive of the GLAM community, and their tool is really, really easy to work with. So if you're interested in learning more, here's a couple resources on the topic: 6 ways machine vision can help museums, artificial intelligence in museums. I refrained from including a QR code, so there are some short and sweet bit.ly links. And if you're interested in sharing the work that you're doing at your museum or some of your ambitions or fears about AI, I would love to hear from you. My email is brendan@qzam.com, and on Twitter, Brendan Sieco.